Awesome. I see that a lot of people are joining, so we'll go ahead and hop in. Hi, everybody. Welcome, and thank you for joining us today for our live webinar, Nirmata Cloud Control Point, EKS and ECS End-to-End Policy as Code with AWS, with our AWS and Nirmata teams. My name is Randy. I will be your moderator for today's session. I do have a couple housekeeping items I want to share with you. This session is being recorded and will be sent out shortly after we conclude. We do want to make this as interactive as possible, so please feel free to put any questions either in the chat or in the Q&A session at the end. I would like to introduce you to our two lovely speakers. We have Bhavya Sharma, who is a solutions architect at AWS. And then we have Anusha, who is our technical product manager here at Nirmata. So feel free to interact with them as much as possible. If you have questions, like I said, for them, put them in the chat or save them for the Q&A at the end. We have a poll to start us off. I will go ahead and launch that. If you could please take time and answer the questions, I will give everybody about a minute to do so. So I just launched it and we'll give you about a minute. The first question is, what is your biggest concern? It is either security, cost, governance, or all of the above. And then what is your current challenge? Managing security, creating policies, or analyzing costs? Like I said, we'll give everybody about a minute. Still see people entering. I'll give you another 10 seconds. Awesome. It looks like all of the above was the biggest concern. And it looks like creating policies was the current challenge, only by just 56%, but managing security came right under that at 44%. So that is very interesting. And with that, I will hand it over to Anusha with Nirmata.
Hey, hi everyone. I'm Anusha. I'm a product manager here at Nirmata. I've been at Nirmata for over 2 years now, and I manage Enterprise Kyberno and Nirmata Control Hub. Nice to see you all.
Hi everyone, I'm Bhavya. I'm a partner solutions architect here at AWS. I primarily focus on containerization and modern DevOps practices, and I'm very excited to be here and presenting to you all. I think we can kick it off.
Yeah. Bhavya, do you want to share your screen and get started?
Sure. I'm having some difficulty looking at the screen. Anusha, is it possible for you to share? Apologies.
Yeah, no worries.
All right. So thank you everyone for joining and giving us your time. I had a quick question before we get started. Who here has seen the graph on the right or can tell me where that graph comes from without looking at the index below? Feel free to put it in the chat. Okay, I'll give everyone some time to answer. You can also raise your hand if you think you know. But in case you don't, this graph, also known as the Capper-Jones graph, was developed by a pioneer in the who founded the whole concept of software economics and the cost of fixing bugs and issues in software. So what this graph shows us is it's very difficult and most importantly, it's very expensive to fix bugs and fix issues once they go into production. And if we look at on the left, some of the metrics that come along with Kubernetes and adoption of Kubernetes, there are a lot of misconfigurations that take place. The number of workloads have also blown up since we are now depending more on microservices rather than a monolith. So there are more interactions, more areas where dependencies or interdependencies can cause issues and bugs which were not there when you have a monolith application. And on average, we have three findings or three security vulnerabilities in any sort of Kubernetes workload. So why is this important? And why is this impact so big? So today we live in an era of platform engineering. Uh, our developers need to move fast. They need to deliver value to the business quickly. And on the other hand, they have this requirement to move quickly, but this comes along with the challenges that, with this huge scale of workloads and huge scale of new technologies, the risks are also equally large. Kubernetes, I'm sure everyone here and all the attendees here can agree that everyone uses Kubernetes, all of your companies. That's why you're here. And it's a powerful orchestration tool. But it's not like it doesn't come with its challenges. So let's set the context a bit. If we want to enable pod security, you have more than 20 controls, and each control has 3 options. That's a total of 60 combinations for one single application in Kubernetes. Scale that up to 50, 100, 200 containers, and it becomes very important that we automate our security mechanisms. We don't want our engineers to be, knee deep, fixing each and every bug manually, trying to debug it themselves. It makes more sense to do it at scale through automation. If we look at the top risks that AWS identified last year, specifically in Kubernetes workloads, our customers told us that the top 3 were insecure workload configuration, supply chain vulnerability, and overly permissive role-based access control. So along with there were some other ones like secret management is difficult, specifically in EKS where it doesn't come natively. You have to use an additional add-on, so maybe something like Nirmata. So all these issues makes it very difficult for a new organization to adopt Kubernetes in a secure manner. So like I said, it's one thing to fix it once it goes into production. Like you can see, if you wait till it goes into production, it'll be 640 times more expensive than if you could fix these issues beforehand, before it even goes into deployment. So that's where something like the admission controllers that Nirmata offer can solve these issues. Next slide, please. So I hope everyone here is familiar with the shared responsibility model that AWS promotes. But in case you're not, I'll quickly give you an overview. AWS is responsible for security in the cloud. What this means is that we at AWS are responsible for protecting the infrastructure that we run in our cloud. So that consists of hardware, software, networking, and all the facilities that we have to make AWS run in a highly available and highly resilient manner. What we expect from our customers, on the other hand, is security in the cloud. So what that means is the customers are responsible for making sure that the software that they run and the applications that they run on our compute instances are secure, are patched. That could include, encrypting your data stores, adding firewalls, doing frequent patching. Depending on the service, it varies, but this particular slide focuses on EKS. So we want to help our customers in implementing security in the cloud. We're not trying to say that we are only responsible for what happens in our data centers and you can handle it you worry about your security yourself. We want to make it easier, and we want to incorporate tools and solutions that make it easier for our customers to adopt security best practices, and that's where partners like Nirmata come in. So when we talk about Kubernetes and a Kubernetes-based application, there are essentially 2 components to it. There are the containers or the applications that are running in those containers, and they're the cluster or the infrastructure that those applications run on. So if we look on the right, HCD, API server, scheduler, the versioning of the Kubernetes, that's something that AWS will handle. But the customer's responsibility would be something like pod security, resource optimization, workload security, role-based access control, and overall networking security best practices. Next slide, please. This also extends what I just said about EKS also extends similarly to ECS, our fully managed container orchestration service. This particular diagram is ECS running on Fargate, but it extends to all the compute options that we have. As mentioned before, there are tools that can help you sort of assist in managing your security, but it's best that we handle the security ahead of deployment. And what we mean by ahead of deployment, the term sometimes you may have heard shift left or do it earlier in the pipeline. So we want to handle all the issues that come up in pre-production, rather than ideally even before it goes into QA, to avoid any additional operational overheads that come along with fixing it later. So like I said, ECS is another AWS managed service, and our AWS users are responsible for handling network configuration, encryption, firewall, making sure that the images they deploy are secure. And the way that we currently do is, I know we did a poll in the beginning of this webinar, and I wasn't surprised when I saw that security management and policy enforcement is a challenge, because IAM is not an easy thing to grasp, especially when you're dealing with a large organization where there are lots of roles, a lot of management involved, and it's not something that was built from the ground up just for ease of use and making it easy for you to manage large scale organizations. There are ways to do it, but usually we see our customers adopting some third-party tools that can help them adopt easier practices and make it easier for them to manage this complexity that comes with large-scale applications. So something like a Kyverno policy is exactly what I'm referring to. Like, that could really help you, address this concern of, I want to prevent something from going into production, or I don't want to deal with IAM. I just want to deal with YAML. I want to deal with Kubernetes native concepts. But I'll let Anusha handle those topics later in the slide. Next slide, please. So how do we at AWS approach security best practices? First, it makes sense to mention that security controls can be different at different stages of application. The goal of DevSecOps is to move security feedback into the pipeline by shifting left, like I said. When you shift left, you are reducing cost and improving overall outcomes of security, risk, and compliance. With security, there are 4 types of controls. That is responsive, detective, directive, and preventative. I'll quickly go over all of them so you understand. So detective controls search to find issues. For example, if you're doing dynamic application security testing, that detects vulnerabilities in running environments or production environments. Directive controls, on the other hand, provide guidance, make recommendations, and helps developers make good choices. An example would be controls that are peer reviews that provide you line-by-line feedback, or something like a static application security testing, or SAST, which scans code to find vulnerabilities, rather than scanning the live application in the case of DAST. The third one is preventative controls, which stops changes from occurring. This is usually using something like hooks, that stops developers from committing insecure code into their repositories. And finally is the responsive control, which takes actions on the developer's behalf. So this can also be called as auto remediation. And this should always be your last line of defense. You should not let your application go into production and then have to remediate it, because auto remediation causes drifts. That is, what you intend the application to be is often what it is, not what it's actually being deployed as. And it often doesn't provide developers with the feedback they need to fix the underlying issue. Without learning the underlying issue, developers cannot learn, cannot improve, they cannot raise the bar for security. So everyone here is pretty familiar with DevSecOps practices. Uh, since it's pretty mature at this age, I think the term has been around for almost 7-8 years now. But with cloud services, organizations need to rethink and reimagine what infrastructure security is. Everyone's aware of application security. It's been around since before Kubernetes. For a long time, people were worried about, buffer overflow and other sorts of application vulnerability. But with the introduction of cloud and using infrastructure as code, having the ability to deploy new servers at the click of a button, we need to dive deeper. We need to look into how we can improve our infrastructure security as well. Could you please, next slide, please? So when we talk about scanning infrastructure, that's what I was referring to, something like Kyverno or Nirmata Control Hub addresses all of our needs. So Gen AI era, right? It didn't leave infrastructure as code and policy as code untouched. You can use something like a predefined Kyverno policy or use Nirmata's Copilot or Policy Studio, which is an AI-powered tool that simplifies and accelerates policy creation by enabling teams to generate, test, and validate policies in real time. With something like Policy Studio from Nirmata, platform engineers can create and test policies directly with live clusters, gaining immediate insights into their effectiveness and impact. This feature reduces the complexity and time associated with policy lifecycle management, ensuring faster, more accurate enforcement across all environments. So on the top, we see AI-powered studio that can help you create these policies. Afterwards, at the build stage, you can use something like Kyverno's integration with Cyclone to do these scans and verify that whatever you're building is as intended and there's no sort of issues in that infrastructure as code. Afterwards, there's also testing. So this is where something like a signature store or SIG store for short can help you make sure that the containers that you have built are the same ones that are being deployed. And finally, you have the deployment and monitoring, where Kyverno can do background scans to make sure that whatever is being deployed in your Kubernetes cluster is meeting your policy and security needs. For example, if if you're a HCLS or a financial services customer, healthcare life science or financial services customer, there might be some requirements that all PII data must be encrypted or all EBS volumes must be encrypted. And that's where something like Kyverno can automatically scan and monitor to make sure that you are always being compliant and never falling out of compliance. Over to you, Anusha.
Yeah. Thanks, Bhavya. That was really insightful. Okay, this is probably a summary of whatever Bhavya said until now. There's this explosion in cloud security and operations, only because there's just so many options for us to deploy our containerized apps. We have Kubernetes, we have serverless options like ECS, all of them great, but they come with their own set of complexities, and securing them becomes a challenge, and that too at scale. The challenge is only getting multiplied. But hybrid multi-cloud is also the new normal. Just in the previous 2-3 slides, you saw an array of AWS services, but if your organization has a multi-cloud strategy, then you have to deal with even more services. Containers are the default packaging mechanisms because workloads are highly dynamic. We are not in the monolith era, we are in the microservices era, and all of them are packaged as containers. And each of them have their own set of requirements, right from resource consumptions to security requirements. Everything is different and dynamic. Out of all the container deployment strategies, at least what we've seen so far is Kubernetes is becoming the de facto standard, although there are serverless options available, which has great adoption, but we see Kubernetes being used more and more. Then we have IAC for provisioning as well. So what we believe is everything is as code, right? Even your infrastructure is as code. You write Terraform files, or maybe you write Pulumi files. Everything is written as code. Your Kubernetes manifests are written as code. or maybe you use CDK, but that's also as code. Now policy also is as code. Everything is a bunch of like thousands of YAML files or thousands of some kind of configuration files. Checking for misconfigurations or security vulnerabilities manually is not possible at all. You need an automated way in order to be able to detect these misconfigurations. And like Bhavya mentioned, we have to prevent these misconfigurations as much as possible. It's great to detect something and try to remediate later on. I mean, that's definitely required because that's the last line of defense. But it's always better to prevent misconfigurations if it's possible. It's not always possible, but we should try to do that as much as we can. And the last point here talks about, organizations spend a lot in terms of security, but we have not seen any slowdown in terms of attacks, right? Like every now and then we hear of a new attack, but it doesn't mean organizations are not spending in security. So where does the problem lie? Like we at Nirmata, we help you with addressing some of these concerns. Obviously, addressing security end to end is a daunting task, but we try to address as much as we can with policy as code. Uh, I want to give you a quick overview of Nirmata and Nirmata Control Hub. Just for the people who don't know about us, Nirmata was founded back in 2013. It's headquartered in San Jose. So we are the creators of the popular CNCF policy engine called Kyverno. So it has the most loved policy engine. It has over 3 billion image pulls, 5,000 GitHub stars, and we have a thriving Slack community of 3,000 plus members. We are the creators of Kyverno and we are the core maintainers of it. Our CEO, Jim Bugwadia, is also the co-chair of the policy working group in the CNCF space. Coming to Nirmata Control Hub. So Nirmata Control Hub is a policy and governance management platform. So it provides you a single pane of glass view of how your environments are performing in terms of, security, policy, operations, and so on. We have divided this into different enforcement points. So when we say pipeline controls, so each of these control points is essentially where you apply these policies. Let's say a developer checked in something into GitHub. That is the first place where we have to run the policy checks. And going back to the shift left strategy that Bhavya was mentioning, the sooner you identify these misconfigurations, the better. The easier it is for a developer to fix, and it's going to cost you less in terms of an organization, because if you find out something is wrong in production, fixing that probably will take 2 to 3 people's effort in 2 to 3 days time, and not to mention the losses that you incur because of your application being down. So we try to enforce all the policies that are applicable in a running cluster at the time of GitHub PR, for example. So these are called pipeline controls because these run in CI/CD pipelines. Then comes cluster controls. So this is, if you all know about Kyverno, this is the classic use case where Kyverno runs in every cluster, and Kyverno is basically an admission controller. So it can either block the requests or allow the request based on whether a particular resource is compliant or not. Then comes cloud control. So this is something very new. We have launched it about 3 to 4 months ago. It's available in beta right now for our customers. So the same use cases and advantages of Kyverno in a cluster, now you can benefit it at the cloud level too. When we say cloud level, let's take ECS, for example. So you are trying to provision an ECS task or ECS cluster with some insecure configuration. Maybe you're trying to pull an image for an ECS task outside of ECR, for example, and your organization mandates that you need to pull images only from ECR. Now, with Nirmata's Cloud Control Point, you can block such misconfigured ECS task definitions too, not just get a report later on saying, hey, one of your task definitions is out of compliance. So that is the benefit of Cloud Control Point. Apart from enforcement points, there are several management capabilities in the platform, like you get a centralized visibility and governance. You can onboard all of your clusters and cloud accounts to Nirmata, and we can give you a very holistic view of the security posture across your environments. There are several RBAC capabilities in the platform, like you can have a security role or a developer role, and each of these roles have different workflows that they can interact. For example, there's exception management. We provide remediation suggestions to developers. Again, going back to what Bhavya was mentioning, developers need to understand if there is a misconfiguration or violation, they need to understand what went wrong, why it went wrong, and what is the correct way to fix it. Because without that, it's very likely that maybe in a future deployment, you're going to cause similar issues. So we try to give you the remediation suggestion in terms of what a correct configuration should look like. And obviously, it's up to you to make that decision whether it works for your environment or not. Then we have continuous compliance. So compliance, policy and compliance goes hand in hand. So we provide out-of-the-box industry standards for CIS, NIST, or it could be EKS best practices. Every cloud provider has, a bunch of best practices that they recommend. And if you paid attention to the shared responsibility picture, so AWS provides security for the services that run in their data center, but then all the workload responsibility belongs to the customer. And making sure their workloads are compliant also is customer's responsibility. So with Nirmata and Kyverno, what we do is we convert all those compliance controls into Kyverno policies. So it becomes very easy for someone to say, my workload is compliant or not. If not, why? So it makes it super simple. Then the Policy Studio, which is our AI-enabled Copilot. So I think one of the poll results was writing policy is one of the major concerns, or that it is hard to write. I agree. Even though Kyverno is completely written in YAML, it is much easier compared to other policy engines to write policies. It can still get complicated if your use case is complex. So we have a policy library. We have over 400 curated policies already present. So I'm pretty sure if you're just starting out, your use case is already addressed. All you have to do is take it and either use it directly or customize it if anything is needed. Otherwise, you can use the Copilot also to write new policies. I'll probably show that today. And then we have a bunch of built-in integrations available as well. Coming to how it works. So like I said, let's focus on this flow where a developer checks in a deployment manifest, for example. I want replicas to be 3, but somehow either by mistake or, intentionally or unintentionally, I set root access to be true. But with Nirmata, you can run all the policy checks that your security team has mandated at the GitHub level itself. It need not be GitHub, it could be GitLab or any version control system. So all these checks are run at the time when this developer has written the code. Let's say this developer created a PR. We run a bunch of checks and then we determine, oh, something is wrong. We fail the pipeline. Now developer gets instant feedback on whatever they're doing is wrong. Let's say if this feedback was not present. What happens when they deploy their application to the cluster? At that time, they have either their application gets blocked, which means now, developer has lost their time in, writing the application only to it being blocked in the cluster. So that's why pipeline controls play a major role in providing that quick early feedback. So pipeline controls is great. Everything is green. For example, my CD pipeline comes into action. It tries to deploy workloads to the cluster. So again, the same set of policies are going to get evaluated because I need to take a break for a second. I'm sorry. Yeah, my dog. Okay. Yeah, so when a CD pipeline kicks in and we have Kyverno already installed in the cluster, we want this same set of checks to be done at the cluster level too. This is again part of the zero trust security principle because we need to do the same set of security checks at every phase of the CI/CD pipeline. We cannot just say, oh, I did all my checks in the pipeline level, my cluster is safe. No, it is not. It has to be done at every level and not just at the time of deployment. You can use Kyverno's background scanning to run this periodically. It could be 1 hour, maybe 2 hours, every 3 hours. You can run this again, the same set of checks, which will generate all the reports for you. So this is an example of when you have a Kubernetes manifest. Let's say you have a Terraform file. You want to provision ECS task definition and you have a Terraform file and your ops person checked in the Terraform file. Again, pipeline controls make sure that whatever is being checked in is compliant. And when the IAC pipeline kicks in, now the cloud controls that we have, even at the cloud control level, we are going to check whether the incoming ECS task definition is compliant or not. If not, it's going to get blocked. So all of these different enforcement points, they just have one job, that is to process Kyverno policies and make sure all your incoming workload is compliant. And how do you view all of these reports, right? Like now you will have hundreds of Kubernetes clusters or hundreds of cloud accounts. So how do you keep a tab of all of your environments? That is where Nirmata Control Hub comes into picture. It's a management plane. Now, if you're a platform or security engineer, all you have to do is log into Nirmata Control Hub. You can see what is the compliance level of each and every cluster, or if it's a cloud account, or even if they're GitLab repos, you can see how each of your environment is performing. So in a nutshell, this is what Nirmata Control Hub is. And I'm going to do a quick demo on each of these control points and show how all of this works together in action. So because there are 3 different control points, I have divided the demo into 3 parts. So if you think it's a little bit slightly complicated to follow along, we have a follow-up workshop. I think Randy can share that information where where you can do this hands-on with me during the workshop. But this is just, think of this as the trailer for the workshop. Okay, so first is shift left with NCTL and Nirmata. So NCTL is a command line tool by Nirmata. So NCTL is the one that's being used in pipeline controls. So you download this NCTL binary and you run the checks. So for example, the platform or security team defines what policies or what controls should be met by the entire organization. So I've called this central policy storage. This could be a GitHub repo or OCI registry, however you want to store your policies, that's great. Now the DevOps user, they set up a CI pipeline, they check in IAC files or they check in Kubernetes manifests, and we already have a NCTL GitHub action available in the GitHub marketplace. So you can use that or you can use the binary directly. It's a CLI, you'll have to download it and run this action. So this particular action will give you that feedback of whether whatever you're checking into the repo is compliant or not. And if everything is green, your CD pipeline can kick in. And we also push all of these results to our control hub, and that is where you can view all the reports in one place. So let me quickly show you. So yeah, I have a repo here called demo NCTL shift left. I have some configuration files. I have Docker file, Kubernetes manifest, I have some Terraform files as well. Because I have ECS here, let me just show you that. I'll quickly create a PR, and while the tests run, I can explain rest of this repository. So let's say I'm a developer. Now I want to make certain changes over here. Let's say I intend to, for whatever reason, do this disabled. I wanted to do this, but also for maybe by mistake, I changed this network mode to bridge. So one of the ECS best practice recommendation is to have network mode as AWS VPC. But I changed it to bridge, and I now try to create a new branch. Okay, update main.tf. Okay, now that I've created a PR, even before I add reviewers and people start reviewing my code, I will have these checks done on my code. So going back to what these checks are, let's go to GitHub workflows. And I just changed Terraform. So let me go to Terraform. So here, these are all the setup things that are required. So this is where I'm installing NCTL. So it's available as a GitHub action. That's why I could directly install it. Then next, what I do is NCTL scan Terraform. I need to tell against what policies I want to scan this. Right now, I have this folder relative to this because I'm storing all my controls here. But going back to our diagram here, this can come from a completely different repository or an OCI registry too. So I need to tell what policies I need to apply and for what resources I need to apply this. And if you look at the controls, okay, I have Terraform best practices. I have a bunch of ECS related policies. So if you're familiar with Kyverno policy, this is slightly different. This belongs to API version JSON Kyverno.io because the Kyverno cluster policy that you know is applicable only to Kubernetes resources. Because Terraform is not a Kubernetes resource, we need validating policy from JSON Kyverno.io. But the structure, everything kind of pretty much remains the same. Even this is YAML. You'll have a bunch of rules where you say on what resource you want to match. Here I'm saying I want to match on ECS task definition. And ultimately, I'm checking that network mode should be AWS VPC. If this value is not true, that is, if the value is anything other than AWS VPC, then this rule is going to fail. So let's go validate that. Just because I changed it to bridge, that should have failed. Let's look at the details. So yeah, it ran, I had about 6-7 policies for ECS there. Everything else passed except for this one. I'm sorry about the indentation here. So it says invalid value bridge, expected value AWS VPC. Now, as a developer, I know that whatever I did was not correct. Maybe I did not even intend to change this, but for whatever reason, it's now bridge. I can quickly go back, update my PR, and this test is going to pass. So this way, I can be sure that I'm compliant with my organization's policies and not have to worry about whether my ECS task definition is going to get blocked or flagged later on in production. So this is the first part of how we can do pipeline controls. So whatever we saw just now was this. Next, let's look at cluster controls, right? And before we go into cluster controls, I know many people know about Kyverno, but just to level set the field, Kyverno is an admission controller in Kubernetes. So all the gray boxes that you see here it's the API request lifecycle. So if you do something like kubectl get pods, the first thing that happens is authentication and authorization. Then comes the validating and mutating admission webhooks. So mutating admission, as the name suggests, can mutate your incoming requests. Validating admission does validation, right? It validates to either true or false. If it is false, then your request gets dropped. It doesn't get persisted into etcd. If it is true, everything is fine. Your workload will be deployed. So Kyverno shines in this area, mutating admission and validating admission. So it's at the core, it's a rule engine. So you write a bunch of rules and it processes these rules. And Kyverno is completely Kubernetes native. When I say Kubernetes native, it means everything in Kyverno is custom resource or controllers. All the yellow boxes you see here are custom resources. So if you look at policies, policy exception, policy reports, all of these are custom resources. So just like you do kubectl get pods, you can also do kubectl get policies or kubectl get policy reports. So all of your native Kubernetes tooling will work very well with Kyverno. So that's why the learning curve is so low, and that's why this has turned out to be one of the most popular policy engines out there. Kyverno can address a lot of these use cases, not just security, like although most people use it for pod security and workload security, but there's things like there are operational use cases. You can use it for micro-segmentation and multi-tenancy. For example, when you create a namespace, you may want to create network policies or resource quotas. All of that can be automated. Software supply chain security. I think even Bhavya mentioned this, like Kyverno integrates very well with cosign, AWS signer notation, and you can verify your container image signatures and SBOM manifest using Kyverno. So with all of these goodness, but I'm going to show a simple example though, because it should not take long. Okay, I already have Kyverno running over here. So let's say I don't have any policies. So CPOL is short for cluster policies. I don't have any policies yet. So if I do something like kubectl run root. So what this is doing is setting host PID to true. It's saying security context privilege true. So this is definitely not a good pod to be running in your cluster. But I got access to this, right? Like now I'm inside the host. I can see, can do ls, I can go to your etc password, I can give a whole bunch of information that you don't want an attacker to see. But let's say what happens when let me install Kyverno policies. So here I am installing pod security policies. I'm installing them in enforce mode. So there are two modes in Kyverno. One is enforce and audit. Audit simply creates a report even though it is non-compliant, whereas enforce completely blocks the report. So I've created everything in enforce mode. So going back to my kubectl, so ideally this should now get blocked, and it does. This is a bad pod. We don't want this pod to be running in our cluster. And admission webhook, it denied the request, and it tells you what all, out of these, I believe there are 17 policies. Out of these 17 policies, at least 5 of them have failed. So this is how Kyverno can protect your environment within the cluster. It can block misconfigured requests from making it into the cluster in the first place. So this is the cluster control part. Yeah, this is the cluster control part over here. Then quickly, I want to show cloud control. For those of you who already know about Kyverno, I'm sure Cloud Control Point is fairly new because even we at Nirmata, we launched it a few months ago. So what is Cloud Control Point? So now we know, think of Cloud Control Point as an admission controller for the cloud, as simple as that. So let's say users are using let's say AWS CLI to provision ECS task, or maybe there is a CD pipeline that is provisioning an ECS task. One other way is you directly go into the AWS console and then you provision a task. So these are different ways, and Cloud Admission Controller tries to act as that gatekeeper where it can block all misconfigured requests. So admission controller is one part. Then we have a cloud config scanner. So this is something like a Kyverno background scan. So this, you can configure it, you can configure the frequency. So it can run every hour or every 2 hours. And then we have policies, just like how we have Kyverno policies, we have cloud control policies. And then there is an event handler. So whenever there's an event that is detected from Event Bridge, the event handler kicks in and then it runs a bunch of checks on those events. So let's say somebody deleted something that they should not have, or they created something that they don't have, they should not have been given access to. So all of those can be checked based on the events handler. Again, all of this information is sent to Nirmata Control Hub. You can use Nirmata Control Hub to get a complete picture of how compliant each of your cloud accounts are. So if there is to be one takeaway for Cloud Control Point, it is that it's an admission controller for the cloud. So quickly showing this in action, um, I need to do some setup for this. I think I'm on the wrong. Yeah. So by the way, you can view all of these getting started steps in Nirmata documentation. So just go to docs.nirmata.io, Cloud Control Point, getting started. So I need to set some. So the HTTPS proxy, basically whatever AWS CLI command I run from here is going to route the request first to the admission controller and then finally to the AWS services. I need to set the cert as well. Oh, okay. I need to change my kube config. Um, oh, the proxy is stopping it now. Sorry. Okay, let's try this again. Okay, so let me quickly show you the pods that are running. So yeah, I have the cloud controller already installed. The Nirmata Cube controller is Nirmata's agent that sends the reports back to Nirmata Control Hub. Let me quickly do proxy, not this. Okay. Okay, something is off, but let's see. Hopefully I have set it in a previous run. Okay, let me port forward it. No, I think I've messed it up somewhere. Probably I'm going to take 30 seconds, otherwise I'm going to not do this right now. Okay, it's some okay. If I set the proxy, it's just not letting me. Even my kubectl command is going by the proxy. Okay. So now that I'm here, let me put forward. Okay, so what I did here was I have a cloud admission controller. I put forwarded this to my local host so that whatever AWS command I run locally gets routed via the admission controller. Okay, so let's put the proxy here. Okay, so now if I need to show the policies as well. Okay. Let's look at the policies. Yeah, just like how you have kget cpol for kget cluster policies in Kyverno, these are validating policies for Cloud Controller. So as you can see, I have a bunch of ECS, there's Lambda related policies, and there's EFS policies and so on. So for example, let's go look at validate allowed registries. So this particular policy, this mandates that we pull images only from ecr.io. So here I'm setting the context that allowed registries is only ecr.io. You can populate this with your own registries. If my ECS task uses any other registry, then this is going to block this request. Okay, I have this. Now quickly, let me go to okay. Now I'm trying to register my task definition where the image is Nginx latest. Yeah, okay. This is where I need to do this, my bad. Yeah, I hope we're not running out of time, Randy.
Oh, you're good.
Have time now.
Okay, thanks. Okay. No, this, okay. Yeah, I always run into this issue. Okay, I got secret. Now all I have to do is export my CA bundle. Okay, this is great. Let me set the HTTPS proxy back. Okay, now hopefully my register task definition has to fail here because I'm not pulling from ecr.io. And here you can see that an error occurred when calling this function and because invalid value, right? Because I'm not pulling from ecr.io. So let's say I change this. And this time I am pulling from ecr.io. And this was successfully created, right? So this way I can make sure that whatever operation is being done, be it create or update operation, all of that gets intercepted by the admission controller and it can either block the request or it can allow the request. Similar to how you have in Kyverno here, it can either block or allow to persist in etcd. Here it can allow to actually create that particular resource. Now, there are different ways to use this. One is because I was using my local terminal, I had to set the HTTPS proxy. But let's say you are using a CD pipeline. So all you have to do is make sure your CD pipeline has access and it can route requests to the admission controller before before it can reach the AWS services, because essentially this acts as a proxy. It needs to evaluate the policies and rules before it can allow creation or updation of resources. And all of this, like I said, we can view in Nirmata Control Hub. So let's quickly go there. So this is Nirmata Control Hub. This is the dashboard that gives you a quick overview of how many clusters, namespaces, repositories are here, what's the policies, what's their status, and so on. So if I go to policy reports, I can see clusters, namespaces, repositories, cloud, all in one place. I can see my demo cluster over here. I can see all my GitHub and GitLab repositories. The demo run that we did here, all of that gets recorded. And as an admin, I can go to any of these repos, or let's go to a cloud account. Let's go to my dev test account. I can see that, in container insights must be enabled, something, passed, failed, or I can see that per service. I also mentioned about, again, if you go to a namespace, or let's go to my demo cluster, and you can view it on a per namespace level, or you can view it on a per resource level. What is the violations occurred? What are all the, we even provide certain remediations. So you can see, if I can find a remediation example. So these are all the findings that are there. So if I can see some resources, yes, there are certain remediations available for this particular resource. I can go view what are the suggestions and I can make those changes. One last point about Policy Studio is that even Kyverno Copilot is up for beta for our customers. So if you're interested, do let us know. We can make this available to you. So I have to answer a bunch of questions. I'm basically I want to write a policy for all the pods in my cluster. Let's say must have label and equal to prod. So this is a simple policy, but I'm saying I want to write a policy for a pod, but not for the pods that start with test, because they're test pods. I don't bother to apply policies on those. And my condition is that they should have label and equal to prod. So a policy gets created for me, nice and good, but I want to know what's the impact of this on my clusters, because it's very tricky to introduce any new policies directly into any cluster. So I can load all the resources from my existing clusters. For example, I go to Cert Manager, I say there are 3 pods, I'll add those resources. And the good thing here is I can do a test run. Now that I know if I introduce this policy, all these 3 pods are going to fail. So if you are introducing this in enforce mode, then definitely you're going to disrupt certain workflows. So depending on your organization's processes, let's say you're a security team, you can inform your app team saying, hey, in 3 months or 6 months, I'm going to introduce this policy. Your pods are failing, make sure you update your pod spec or your deployment spec to ensure to comply with these policies. Otherwise, after 6 months, your pods will start getting blocked. So this gives you a very nice way to view what's the impact, or what is the size of impact across your clusters. And you can safely introduce policies, keep introducing new policies, because you start with the bare minimum policies, but the goal is to have more and more security and operational related policies in your environments. Yes, and I'm going to take a break.
Awesome. Thanks, Anusha. I appreciate all the information.
Awesome, Anusha.
Yeah, that was great. If anyone, we have a few minutes left. If you have not had the opportunity to put any of your questions, let's go ahead and do that now so we can at least address a few, either in the Q&A box or in the chat, whatever you feel comfortable with. I will give everybody like a few, like 30 seconds to start doing that. And then we'll try to get as many in as possible. And if we don't address them, we can always take that offline as well. So like I said, if you have any questions, please go ahead. It looks like I do have one question. How do you validate policies against existing resources?
Yeah, I think that's pretty much what I showed towards the end. So, with Nirmata, you can, uh, you don't, Policy Studio, so Copilot is just one aspect of Policy Studio, but we want Policy Studio to be your go-to, tool to write new policies, to test new policies, and also to see the impact across your environments. So you can just use this as a playground, for example, just copy paste your new policy if you already have written somewhere. And you can upload your test resources or the best ways to see what's the impact for your current environment. So you can load resources from your current clusters and then see how it behaves. Like if something is wrong, it gives you a nice error on, whether your policy is not formed properly or your resources incorrect. So it helps you to debug policies as well. So I would say Policy Studio is a very good place for you to try to learn to write policies and also test your policies.
Awesome. Thank you. I have a couple what are the other use cases policies can help with? Cost management, or are there any others that you can name?
Yeah, so like I said, the use cases of Kyverno are very wide. So cost management, definitely, I think we've done previous webinars on resource optimization and cost optimization. So Kyverno is a CNCF tool, right? It combines very well with, or it integrates very well with other CNCF tooling, like it could be VPAs, HPAs, and using those tools, you can uh, come up with niche solutions, such as, in the resource optimization case, what we did was based on the recommendations by VPA, Kyverno was able to fine tune the resources. So now that you're not over provisioning or under provisioning the resources, you're in turn saving costs as well. So that is one
I'll can also answer.
fantastic
Nusha.
solution.
I'll,
Yeah.
I'll give you a break. If I were to answer like the top three use cases for like a policy engine like Kyverno would be security best practices, which Anush already covered. Then there's also compliance requirements, being able to meet those. Let's say you have a compliance requirement with PCI DSS where no node should have a public IP. So that's something that Kyverno can actually help you implement. And then there are also, operational best practices that these policies can help you implement. For example, having a requirement that all pods must have replicas, or making that's one example, or having at least medium-sized storage instances, uh, stuff like that. So those three would be my top use cases. But Anusha, I don't know if I missed any.
Yeah, I think you covered it pretty well.
Awesome. We have time for one more question. It looks like William has a question. It says, you mentioned about applying policies after a certain time. Can you automate a new policy rollout after a certain amount of time?
Let's say user X policy will roll out after 3 months. That can be automated and rolled out after 3 months. Well, I mean, if you follow GitOps principles, you can choose to like have it in your GitHub repo and sync it whenever you want. So you can then roll it out after 3 months, 4 months, or whatever, or whenever you're comfortable with. Or even a better way to roll out a policy is to always first introduce it in an audit mode so that you know it's not disrupting anything, but it's there. And eventually, when you see all of your resources are passing, just switch it to enforce mode. So I would not wait long just to introduce the policy, but a safe way is to introduce it in an audit mode.
Awesome. Thanks, Anusha. I know we have a few more questions, but we're up at time. So I will make sure to reach out to you directly with those questions. I did want to take a second to thank our wonderful presenters, Anusha and Bavier. We really appreciate you with all the knowledge that you gave us today. I did put a link to the live workshop that follows this webinar in the chat, and then I'll also send it as a follow-up with the recording. So thank you all for joining today's session. We appreciate you taking the time out of your day. Once again, special thank you goes out to our wonderful panelists and speakers. We appreciate the insight. This session will be sent out, like I said, so be on the lookout for that. And I hope you have a great rest of your day. So thank you all. Appreciate you.
Thanks, Randy. Thanks, everyone. Thanks, Bhavya.
Thank you.
Bye.